Hello everyone. Today we will explore an important concept in networking, that how devices communicate and troubleshoot issues over the internet. Our focus will be on ICMP version 4, which stands for Internet Control Message Protocol version 4. This protocol plays a key role in reporting errors and diagnosing network problems, ensuring smooth communication between devices. Let's start with an introduction to ICMP version 4. ICMPV4 is a crucial part of the Internet Protocol suite. It is mainly used to send error message and operational information about network communication. Unlike TCP or UDP, ICMP is not used for sending actual data between devices but helps in diagnosing networking issues. For example, if you try to access a website and the server is down, ICMP sends a message back informing your computer that the destination is unreachable. Think of it like a postal system. If you send a letter to a wrong address, the postal service returns it to you with a note saying address not found. ICMP is responsible for sending error message such as destination unreachable and a control message such as echo request or reply for a ping. Now that we have understood what ICMP v4 is and why it is important, let's dive into different types of message. ICMP messages are broadly classified into two categories. First one is a error message and second one is a control message. First, error message. These messages inform the sender when an issue occurs during the packet transmission, preventing it from reaching the destination. For example, there is a type 3 error message, which is used for the destination unreachable. It is sent when a packet cannot be delivered due to reasons like non-existing host or a block network. Second one is a control message. These messages help in a network diagnostic and communication management. For example, echo request and echo reply. It is used in the ping command to check if the device is active on the network or not. These messages play a crucial role in keeping networks functional. Just like error alerts on your phone tells you when a message fails or a read receipt confirms delivery. Here are some important error message and a control message listed on the slide. Now we know the type of ICMP message. Let's look how these messages are structured in a packet form. An ICMP version 4 packet consists of the following key fields. First one is a type. It identifies the type of ICMP message. For example, it identifies that the message is an echo request or a destination unreachable request. Second one is a code. It provides additional information related to the type. For example, if it is a destination unreachable, then different reason for an destination unreachable. The third one is a checksum. It ensures the data integrity by detecting the errors in transmission. Fourth one, rest of the header. It varies based on the ICMP message and its types and carries additional details like IP address or original IP address of the header. Last one is optional data. It often includes the original IP header and a part of the original data, helping the sender diagnose issue. Think of this like a postal return slip. The type tells you why the delivery failed. The code gives extra details. The checksum ensures the message is valid, and the optional data helps identifying the original request. Now, let's look at the ICMP error message in detail. ICMP error message notify the sender when a network issue prevent a packet from reaching its destination. Here is one example of type 3 error message, which is related to destination unreachable. This is the ICMP error handling process. That first one is data packet sent to a sender. Then that data packet is received by the router. Router checks its reachability, that is destination reachable or not. If the destination is reachable, it forwards that packet to the destination. But if it is not reachable, then it generates the ICMP unreachable message. That message is again sent back to the sender, and sender recognizes exact issue, that why the destination is not reachable. So this is the typical flow of ICMP error handling process. For better understanding of ICMP error message, here is a second example. TTL expiry and ICMP time exceeded flow. Every packet traveling through a network has a time to live, which is a TTL value, which ensures that the packet do not circulate indefinitely. Let's see how the ICMP handles the TTL expiration. First one, data packet sent. A device sends a data packet with a TTL value. The packet moves through multiple routers to reach its destination. Every router that processes the packet decreases the TTL value by 1. Suppose the value of TTL at initial is 5, then it transmitted in 3 different routers. So now at this position, the TTL value of the message is 2. If the TTL reaches to 0 in between the routing, then that packet is discarded, meaning the router generates an ICMP time exceeded message, which is a type 11, and sends that message back to the sender. The sender gets the ICMP message indicating TTL expiration. This helps in diagnosing routing issue and networking delays. Think of it like a courier with a limited number of checkpoints. If it reaches the last allowed checkpoint without delivering the package, it is returned to the sender with a failure notice. ICMP is not just for reporting errors, it also plays a key role in network diagnostic. A perfect example is the ping command, which helps check if a device is online and reachable. How it works, let's see. Sending an echo request. A computer runs the ping command to check connectivity with a target device. It sends an ICMP echo request, which is a type 8 packet to the destination IP. If the target device is online and reachable, it responds with an ICMP echo reply, which is a type 0. This confirms that the device is active and connected to the network. The sender records the time it takes to receive a reply. A fast response means a good connection, while delay or a timeout indicate the network issue. Think of a ping like a calling someone to check if they are available. If they pick up and respond, you know they are online, just like an echo reply confirms a device is reachable. While ICMPV4 is useful for network troubleshooting, it has some security and operational limitations. First one is a DOS attack, denial of service. Attackers can misuse ICMP by flooding a system with echo requests, which are the ping command, consuming its resources and potentially crashing it. For example, in a ping flood attack, a server is overwhelmed with excessive ping requests, making it unresponsive. Second one is a firewall blocking ICMP. To prevent attacks, many firewall block ICMP traffic, which can interfere with legitimate network diagnostic. For example, if you try to ping a website and get no response, it may not be down, its firewall might just be blocking ICMP request. Third one is a device ignoring ICMP. Some server disable ICMP response as a security measure, making it difficult to determine networking issue. For example, a server may be online but won't respond to ping if ICMP is disabled, leading to false assumption about its unavailability. In short, while ICMP helps diagnose network issue, security concerns often limit its usage in real-world network. To wrap up this session, ICMPV4 is an essential protocol for network troubleshooting and diagnostic. It detects and reports network issues when packet delivery fails, for example destination unreachable or time exceeded. Control messages like echo request and reply help verify connectivity using tools like a ping. Traceroute utilize ICMP to map the path of packet across a network. While ICMP is crucial for monitoring and communication, it has limitations such as security vulnerabilities and firewall restriction. Despite these challenges, ICMP remains a vital tool in maintaining efficient and reliable network operations. Thank you.